paging and swap files. Together, you and me will unravel the secrets of SAP HANA Dynamic Tiering. Understand pro tips and best practices for optimizing your virtual machine disks for SAP and get an understanding of NFS and SMB storage. This video will help you make the best decision when creating an architecture for SAP environment, or if you are just starting out in Azure, you will find this video immensely helpful. But that's not all. We will also convert our Terraform code into modules, laying the groundwork for the next set of resources we want to create, like setting up virtual machines, load balancers, and more on our exciting journey through Azure. You can of course follow along by cloning my Git repository. The link is in the description box. Hey guys, welcome to your own channel Certheads. My name is Rajdeep. I am a Microsoft certified trainer, and together we are on a mission to crush AZ-120 SAP on Azure certification together. In our last videos, we discussed about VM caching and the concepts of managed disks. Now let's continue the discussion on that deep dive in some crucial storage concepts. Let's get started. Alright, imagine you're tasked with setting up SAP environment on Azure and you have an opportunity to select a virtual machine to get the most out of its performance. Now here are some of the crucial areas to focus on in order to optimize the VM paging and swap files. You might have heard these terms interchangeably. Page is the term used for Windows and swap is Linux. They pretty much mean the same thing. So there's a little power hungry app which you have. I'm talking about something that's just gobbling up all your RAM like a Pac-Man on a mission. And what happens when your RAM runs out? This is where the swap files comes in as a handy backup. The least used programs in RAM are swapped up to the hard disk, making space for other programs to load into RAM. It's like your system gets a little extra brain power even though you don't have enough physical memory installed. That's a pretty neat thing. How do you configure paging and swap magic? Well, if you are running Windows, the page file should be placed in the D drive. Now the fun fact is, D drive on Azure VM is actually a non-persistent drive. This means when the VM shuts down, D drive data vanishes, but it's perfect for swap files because they get recreated on boot. Now you understand why you have a temp D drive on a virtual machine. Okay, and what about Linux? For Linux, swap files can live under /mnt/resource. You can set this up using configuration file called WA agent. Don't forget to restart the WA agent service after you have made any changes. Otherwise, the changes would not stick. Moving on to the disk best practices for SAP, you remember we talked about managed disks. So it's no surprise that using managed disks for your SAP workloads is a no-brainer. And hey, if you're working with M series virtual machines, make sure to enable write accelerator for log file updates. Also, let's not forget, we should be using premium storage. SAP isn't cool with hard disk drives. Let's configure page files on Windows VM and see how it's actually done. Okay, I have created an Azure VM. Let's log into the VM. First, we'll open up System Properties, navigate to the Performance Settings under Advanced tab. There's an option for the virtual memory. This is where we manage our page files. From there, we can customize the size of the page files based on our system needs or set it to be automatically managed. Remember, we use D drive in Azure to ensure optimal performance and avoid any impact on our primary OS drive. The system will restart. What is a multi-disk volume? That's when you combine several disks into one larger volume. The magic here is striping. What is striping? Striping is where you take data blocks and spread them across multiple disks. So instead of one disk handling all the data, you have got multiple disks sharing the load. This means higher combined IOPS and aggregated throughput and more storage. Striping is also referred to as RAID 0. What is RAID 0? RAID 0 is a redundant persistent array of independent disks level 0. In RAID 0, the data is split and written across multiple disks, allowing for faster read and write performance since the workload is spread out. This is especially useful for SAP environment where high I/O is essential for performance. Now, following SAP's recommendation, you can stripe multiple Azure data disks on Windows using Disk Management utility to boost your I/O bandwidth. On Linux, you can use MDADM utility for striping. Just remember, small stripe sets for smaller I/O requests and larger stripe sets for big sequential I/O tasks. Now, striping is out of the way. What are the other options available to you? One of them is I/O scheduling mode. This is basically how the system decides the order in which the input-output operations are performed. For Linux, the command is CFQ. What is CFQ? CFQ stands for completely fair queuing. It is like a theme park. You get a fair shot at the rides based on how long you have been waiting in the queue. But SAP says you should use Noop mode. Noop mode is simple first in, first out. It works great for random access devices because it processes I/O requests in the order in which they come. Last but not the least, let's talk about caching best practices. For HANA data and HANA log volumes, don't use caching. For HANA shared, use read caching, and for M series VMs, use write accelerator. It's like giving your storage an energy drink. In the previous slides, we mainly discussed about configuring the infrastructure or disks to get the best output suited for SAP workloads. Let's understand what SAP has to offer in terms of managing data to make it more efficient. SAP HANA Dynamic Tiering. Let's start with the basics. What is hot and warm data? So imagine hot data is like that important text from your friend you have been waiting for. You're checking it frequently. In the world of SAP HANA, this kind of data is stored in memory, meaning it's lightning fast and used all the time. Hot data is basically the VIP of storage. Now, warm data. This is the stuff you don't need every second, but you still want fast access when you do. It's like an old playlist you haven't listened to in a while but might revisit soon. It can sit on a disk which is slower than in memory but still needs to be quick enough. So it's all about finding that balance. Now, how do you segregate hot data and warm data? Here's where SAP HANA Dynamic Tiering or DT comes into play. DT is an add-on for managing warm data, helping you offload that less frequently accessed data from in-memory to disk. It's like giving your warm data its own comfy home on a disk instead of crowding up in the memory space. DT basically extends HANA's memory by adding a disk-based storage solution. Super handy when you are dealing with a massive database of over 512 GB. But wait, not everyone can jump into the dynamic tiering. If your database is over 512 GB, then it makes sense to offload the warm data to DT's disk-back storage. Oh, and for SAP nerds out there, this is supported for SAP BW on HANA and SAP BW for HANA, but as of now it is not supported for S4 HANA. You might need a separate VM to install DT, but don't forget you should be using accelerated networking. Put SAP HANA and DT in the same VNet. Premium storage and disk striping are your best friends here. So what VM types can you use for DT? So as of now, you can use M64 32MS and E32 V3 VMs. But there's a plot twist. SAP has deprecated HANA Dynamic Tiering. Yep, it's still around, but don't expect any more shiny updates. So what does that mean to you? Well, the big recommendation from SAP is to migrate to SAP HANA NSE. HANA NSE stands for Native Storage Extension. That's the future of warm data management. Now, the $1,000,000 question here is, what's the difference between NSE and DT? With NSE, warm data stays in a separate area of SAP HANA memory called the buffer cache, while DT moves data back and forth from disk to memory whenever it's needed. NSE is a bit more streamlined, keeping things in memory rather than swapping them from the disk. Plus, NSE comes with a cool advisor that gives you recommendations on whether to page load or column load certain tables and partitions. It's It's like having a data management assistant guiding you. So we have used paging and swap files, multi-disk volumes and striping, and also data tiering. Pretty neat, but there is more. SAP has created its own set of recommendations, also called SAP Notes. You might notice there is some overlap between the things which we have already discussed in our other videos, but always remember to check the OEM's recommendation to get the most up-to-date info. Now coming back to SAP Notes, you need an SAP SID in order to access these notes. It's like a subscription pass to get the official details, but don't worry, you can still refer to Azure documentation and find out the gist of these SAP notes. Alright, let's start. SAP note number 2015553. What does it say? This one is all about getting the most out of your Azure storage. Here's what it recommends. First up, it recommends you perform striping. Yep, this method again. If you want to boost your total IOPS per volume, SAP says striping is the way to go. Combine multiple disks, increase your overall throughput. It also tells you to separate your DB and log files and also keep them in different volumes. And whatever you do, remember, do not use the D drive because that's a non-persistent drive. Where do we use the D drive? We use it for paging. Next, we have got SAP note number 1928533. Let's understand what it says. It says that keep your SAP application layer and the database layer in different kind of drives. So at the minimum, for the application layer, use Azure SSD, and if your database is super sensitive to latency and super performance hungry, then use premium disks. Don't skimp here. Premium storage gives you that extra boost that you will need. Finally, let's talk about SAP note number 2101553 and 2367194. Both of them emphasize on one major point. If you are dealing with databases, use premium storage, and that's it. SAP Notes are a treasure trove of information, especially if you are planning a production deployment on Azure. Always refer to them. These notes are your single source of truth. They'll help you avoid headaches down the road. By the way, if you're new here, make sure to hit that subscribe button, tap the bell icon, and if anything is unclear and you've got some thoughts, just drop a comment below and let's keep the conversation going. Alright, let's jump into something pretty cool, NFS. So what exactly is NFS and where do we use it in the SAP landscape? NFS stands for Network File Storage. It is primarily used in Linux-based systems, and when it comes to SAP, we use NFS in scenarios where you might have multiple application servers. So basically you are running a bunch of application servers and NFS helps them to talk to each other. So how do you actually set it up? What is the process? There are three options. If you are using SUSE Linux, you can use DRBD and pacemaker clustering. Now we have got another video explaining pacemaker in detail. Check that out if you want to. You have got RHEL, no problem. You can go for GlusterFS clustering. And if you don't want to deal with VMs at all, you can use Azure NetApp files, which is super easy and it's a managed solution. It's an enterprise class, high performance file storage service. Now let's talk about its Windows counterpart, SMB. SMB stands for Server Message Block. It's the shared file storage protocol for Windows systems. In SAP landscape, SMB is essential for highly available file storage and when you're working with Windows-based setups. SMB essentially serves the same purpose as NFS, the only difference being SMB is in Windows and NFS is in Linux. Now, how do you set up SMB? What is the process there? In order to set up SMB, you need to set up Storage Spaces Direct along with SOFS, which is Scale Out File Server. And how does Storage Spaces Direct work? Imagine if you have multiple servers and you want to combine all the storage into one large pool. Storage Spaces Direct lets you do that, and then by clustering those servers together you can create an SOFS on top of it. It functions similarly to NFS. But you might ask, why not use Azure file shares instead of all these VMs and using a Storage Spaces Direct? That's a good question, and yes, you can use Azure file shares as well. Now this kind of setup, SOFS and Storage Spaces Direct, was more prevalent when you had on-premises setup, but now since we are in Azure, we have the advantage of using Azure file shares as well for all our SMB storage needs. Okay, let's talk Terraform now. What exactly is a Terraform module? Well, think of it as a neatly packaged directory that contains all the configuration files you need. These modules can be reused across different projects and teams. In a way, modules in Terraform is similar to functions in traditional programming. You pass a set of values to the module, it's like a black box, and this module will create your resources which you want without you needing to know what's going on inside that module. The module can be like a black box. For example, if you create a resource group.tf module, you can just pass the values to that module and expect that the module can do an internal computation and give you an output. Let's understand some of the uses of a module. First use is reusability. So you can create the module once and use it across multiple projects. Similarly, you can use it for versioning. It provides us a bit of encapsulation, which means it helps you group your related infrastructure together and hide the complexity of a particular resource. It has an improved readability as well, because when you're using modules, you're not actually writing everything in your main.tf. You're just calling or referencing the modules. The actual logic is written inside the module. So you're hiding the complexity and you are making the code more readable. It is also scalable. So instead of rewriting the same code again and again, you're just calling the module. Now the big question is, how do you actually modularize your Terraform code? Let's head back to our Terraform code and we will create modules out of our small code. And don't worry if you're coding along with me, just clone the GitHub repo which I provide in the description box. I update it regularly with all the changes we are making so that you can follow along step by step. Okay, let's come back to our code. The first thing which we will do is comment out the main.tf. Then we will create a folder called modules. Under modules, we will create 3 folders: resource group, subnet and vnet. In each folder, we will place 4 files, namely main.tf, outputs.tf and variables.tf and readme. So I'll tell you why these files are created. The main.tf is basically the resource file via which you tell the module what it needs to create. The variables, you have to have variables file for each module where you pass all the variables, and the outputs which you want this particular module to pass out shall be put in the outputs. So now let's create the resource group. Let's click the copy on the code and place it in the main.tf file. We'll uncomment this and our module is ready. We just need to declare the variables. We had already declared the variables in the base folder, so we will just copy paste from there, and these are the resource group variables. Let's paste it here, and then we will declare the outputs. So we want the resource group name and the resource group ID. So let's name the output as output resource group ID, and the value is coming in from the Azure RM resource. The value is ID. Similarly, we will create another output which is for the resource group name, because we will be using the resource group name in our modules, and the resource group name, and that's it. The module is ready. The readme, we will just say this module will create a resource group. So with the similar principle, I have created the vnet module as well. Now as you can see, I have declared that I want to create a vnet resource, and I am picking up the name, the resource group name and everything as a variable inside the module. And when you declare a variable inside the module, you basically have to declare the variable again when you're calling the module in the main.tf. I'll get to that later, but the outputs which I need from this module is the VNet ID and the VNet name. Similarly, for subnets, I have declared that I want to create the subnet resource and use a for each loop, and the resource group and virtual network, I am picking it from the variables. So you can see there is a readme file in each of the module. So it helps if you create a module and you put a readme file and you put some description about the module. I have not done it now, you can do it later. Let's come to the main.tf and understand how we have stitched the modules together. As you can see, I have called the module rg-create. This is just a name. You can declare any name you want. The source is, however, important. Within double quotes, I have given a dot and a slash, and I have directed it to the modules folder. And inside the modules folder, there is a resource group folder, and inside that resource group folder is our module. So you just need to give the path as a source, and then it'll ask you for certain variables which it needs. For example, it needs the location and the resource group name, which I have passed via .location, and you have to declare this in the variables.tf file as well under the root. So after doing that, we create the VNet. We just name the module anything we want, and the source will be modules/VNet. Under that, we can give the VNet name, which is I have passed in through a variable. The address space I have passed in through a variable, and the location I have passed in through the variable. However, the VNet RG has been passed in from the previous module. So as you can see, I have called the previous module. Just say module dot the name of the module which you're calling. I'm calling the AZ Certhead RG create, and from that, the output which I am demanding is the resource group name. So now you understand why we have created an outputs inside the module. Coming back, I've created the subnet, so I've called the module AZ Certhead subnets. The source is modules/subnets folder, and the VNet name I am calling in from the previous module, which is AZ Certhead VNet dot the VNet name, because I have given an output under the VNet. I want the output of VNet name and the VNet ID. The resource group VNet RG, I am calling the resource group module, finding out the name from there. Subnets I have passed in through the variables var.subnets, and the location I am passing in from the variable. Now we have declared all the variables. So what we have done here is we have significantly reduced the number of lines in the code. It looks much cleaner now, and whatever computation has to happens inside the modules. So from now on, we are going to use this structure for creating any resources which we want to create for our lab for SAP. If you want to follow along, you can just clone the repo which I maintain. The link of the repo is in the description box. Okay, now the code is ready. I have formatted it. Now let us run a Terraform init. We need to initialize the Terraform since we have added new modules to it. Let us run the init command. Terraform is initializing the backend, and it has successfully initialized. Pretty good. Let us go ahead and create a Terraform plan. We need to understand what Terraform is going to apply, what Terraform is going to create. So let us run the Terraform plan, and it says 6 resources needs to be added. I'll apply it just to test out if everything is working fine. And Terraform has applied, and 6 resources are created. Perfect. That brings us to the end of the demo. Alright Certheads, that's a wrap for today. We have covered essential strategies to optimize your Azure VMs for SAP, walked through page file storage, and even modularized our Terraform setup for smoother scalability. If you found this video helpful, be sure to give it a thumbs up, and if you are new here, hit that subscribe button and ring the bell icon so you don't miss out on any future labs and deep dives. Let's keep pushing those tech skills to the next level together. Until next time, happy learning, and I'll see you in the next video.